So today I'd like to talk about construction drawings, specifications, and contracts, and that conveniently is Chapter 6 in our textbook, Construction Drawings and Details for Interiors. First of all, this reference book, this construction drawings book, is really a good, thorough book. It doesn't have kind of everything about how you should detail, but what it does do is kind of outline the overall strategy for how to produce these drawings. And really, at this stage, it's very important for you guys to use your reference books. There are many things that you don't know, and the farther along you get in the profession, the more you realize there's even less that you don't know, but you do need to know how to find the answers. Okay, so and believe it or not, actually, a lot of times these reference books and this Kilmer and Kilmer book is very good. It has a lot of nice checklists, which are handy when you're working in an office. But even interior design graphic standards or architectural graphic standards, it's sometimes faster to find results in those resources than it is to go and hunt around in Google. And of course, you never know quite what you're going to get with Google. All right, let's talk a little bit about contract documents. Now, I am not going to go and read every single element of these slides. In fact, these are horrifically wordy slides. But because this is a recorded lecture, I actually thought it was okay. But I will kind of try to cover the highlights. First of all, contract documents, as I mentioned earlier in the first class, are comprised of several different things, all specified in your contract. Typically they include specifications and construction drawings. Okay, so drawings and specifications. It's basically, that's the recipe for how people are going to build your project. There are a large number of different things that can go into construction documents depending on the type of projects. They come in all sorts of different flavors. But typically the drawings and the specifications work together. They do not duplicate information. They work together. We'll talk about that in a couple of minutes, or right here. Basically, for example, this is a good one. Drawings show the color and location of a paint applied to a wall. That may show up in a drawing or on a schedule on the drawings. They do not tell you how it's applied, any VOC limitations, any sourcing information. They may not have multiple products. All of that stuff shows up in the specifications. So the specifications are written documents that are typically going to just tell the contractor specifically what you want. Not always, though. They are sometimes, as we'll see, written in manners that allow the contractor to provide ideas for the material. But in this case that they're showing here, it often has information about sort of how something is applied and the level of craftsmanship and workmanship necessary. So specifications for a small project can be placed right on the drawings, and in fact, in a particularly small project, it may be that they're only part of a title page. This is actually I have a drawing set that I will be bringing into class that looks kind of like this. It's just one page of specifications, and you can see here it's a little hard, I'm sure, on your tiny little screen or phone, but they've actually broken it up by CSI division. So there is an organization to specifications, a whole system. Also common in more complicated projects, or just ones where the specifications are more critical. They are bound in a separate manual or put on a CD or DVD if you've ever seen one of those. There are different kinds of two general kind of classifications of specifications. One is closed, where basically you give us that product or nothing else, or open, which allows the contractor to suggest stuff. And within these flavors, I guess there's more specificity here in the specifications. The 4 different main types. We'll just take a look at each of those. Proprietary specifications are the ones that are basically closed. This is probably most common for non-public work. So you might be designing a dentist office or something like that. There is a specific product you want used. Descriptive specifications are generally open in that they don't have a manufacturer, although sometimes I know that I have used descriptive specifications and used a manufacturer as an example, which is actually probably not a good process. But anyway, they are a little more difficult to write. Reference specifications are the type of thing you often see in a public project where you want the contractor to find the cheapest material, but it has to meet standards, and these standards are probably going to be based on the type of project and the level of quality that you need. But they are nice and short. However, they are also kind of difficult because you actually have to know what those standards are. Finally, performance specs are the type of spec where you basically say what you want it to be able to do, and then you kind of throw it back to the contractor and say, you find something. And any product that they can come up with that meets your criteria can be used. And sometimes people will use a sort of pseudo performance spec where they say, give me, Benjamin Moore, 0 VOC, et cetera, or similar. And that or similar throws it back to the contractor for ideas. Okay, the organization of specifications is based on what's currently known as the master format. And if you work in an architect's office, they're going to have some giant master format database for all sections available. But the CSI, it's also commonly known as the CSI format. They're the people who publish the whole thing. And it used to be 16 divisions, so all the old-timers like me who were in practice before 2004 are used to that. But now it's sort of this massive, I think there's 40-something sections. It's pretty wacky. But basically the idea is that any product in a project has a number. Okay, that's the overall kind of organizational system. When we get to spec writing, we will cover this more. The only thing that actually is critical at the early stages of design is that you should be aware as you create your elements in your Revit projects and that kind of thing, that the family types that are within Revit can be used to generate these master format specifications, but you have to use the product information that you know is in there. So often, in an early stage in the design, you might be just using kind of proxy objects that are masses or other things. But as soon as you can, putting in objects that follow that, or at least have this CSI information in them. And you may not even have ever noticed it, but in the properties of your typical door, it may have the CSI section in there. So anyway, there are so many subgroups, and basically it's just a kind of outrageously complicated thing. In fact, I've posted the full list of all of the 50 divisions on Canvas for your perusal. You won't need it at this stage of design, but just be aware that everything is organized this way. In fact, for our projects, for your typical interior designer, there's really kind of 4 sections that you're mostly worried about: finishes, specialties, equipment, and furnishings. Obviously, sometimes you're going to be specifying masonry or wood, plastic, that kind of stuff. Even conveying equipment like elevators. However, probably if you're on a project where they're adding new elevators, you're probably not going to be doing that. You're going to get a specialist. And there's so many other sections in here. It just kind of goes on and forever and ever and ever. So anyway, the book has an appendix with an example from an interiors project. So absolutely make sure you check that out. Okay, so that's the organization of a project, an interiors project, the construction drawings. Let's talk a little bit about contracts in greater detail. The book, I believe, mentioned, and I may have mentioned, that they can be oral or written. But obviously written is preferred because it's a legal document. In fact, I would basically say, unless you're just renovating somebody's kitchen, I would never go without some confirmation that you're going to get paid. And this is particularly important if you're a solo practitioner. As mentioned, there are contracts which are kind of pre-made for you from the AIA are the ones that I prefer, but that's because I'm an AIA member and I'm trying to drum up some cash. Also, they are probably the most prevalent, but ASID, IDA, they both have examples. Here's one from ASID. And again, there's different sections. And the thing about these contracts is that they cover you when you're working with an owner. They make absolutely sure that, one, the owner and you each know what everybody's expected to do, what your work is and what you're going to get paid. But it also allows you to add in additional things, for example, making a model or something like that. Also, not every interiors project has a full set of construction drawings, or working drawings as they're called. And then some projects, all it is some sketches, and a contractor kind of takes it and runs with it. So how are construction drawings or working drawings organized? Basically, in a general sense, most drawings are kind of very technical in nature. They are not meant to be, presentation drawings, which is what we're mostly at. And interesting enough, our lovely Revit program just loves doing construction drawings. In fact, there is a whole construction template, which when you go and create a new project, Revit has that option. And that is great for construction drawings. Now, we are not going to use it because transitioning from a schematic design to the construction template, I was worried that it would be just a little too complicated. And so we will start with the architectural template. That's more for design. Or we have started with the architectural template. But the construction drawings in an office, they will often have their own template, which has all sorts of goodies in there, title blocks and other fun things. We will learn how to import that stuff into our project. So the organization of these sheets, this is the typical way. Again, I must emphasize, if you're in an office, just see how they do it. Okay, architects versus interior designers are going to have their own kind of happy way of doing things, and so make sure that you check how they organize it. But typically the title sheet is first. Of course, that kind of makes sense, followed by plans, sections, and elevations. Okay. Sometimes people put the building sections and wall sections together. Some people will put wall types, which are also a type of section, up early after the floor plan. Again, it's variable. And an interiors project, obviously you're going to be jumping right to things like the finish plan that may be right on the first floor schedule, or there may be a first floor plan, finishes plan that shows up after the main plan. So anyway, and it keeps going on and on and on. And basically anything that you can put in a project, that you put in your project, needs to be on the drawings somewhere. And here they mention putting the specifications at the end. Although, interesting enough, I have always seen them at the front. I don't know why that is, but anyway, for a small residence, they just have a nice example in the book. Obviously, it's too small for you to read all the details, but you can see here that the drawings are laid out on a nice sheet, title block on the right. The I prefer the vertical title block on the right myself, just because when you roll this up, you'll be able to read the name of the project and the sheet number or address or dates or anything like that. Anyway, and in a small residence, there's not a lot going on. You can see there's just a few interior elevations, not the entire project elevated, and they have an electrical plan, which is actually kind of an odd thing if you ask me, but maybe that was the scope of their work. So a larger project, they are not going to show every single drawing, but you can see here, first of all, there's a list of sheets on the title page. I also happen to like these examples in the book because they are technical drawings. You can see the title block is, mentions the project number, name, address, the designer's name and address, but they're a little nicer than the Revit templates. I cannot tell you how sick I am of those Revit templates. So please change it. Please help me out. Anyway, there are certain basic elements in these larger projects. You start to see things like keys to abbreviations and architectural symbols. Again, larger projects are just more complicated. There's more people involved. You need to define how, what sort of language you're going to be using in your design. You may not be sitting down with every single subcontractor to talk about, I don't know, the tiles in the bathroom or something like that. So everyone needs to see these right up front. Okay. Also, design factors, that's a funny thing to call what appears to be building codes. Whatever. Anyway, the set obviously is numbered and bound almost always on the left side, and so which is why a sheet of construction drawings, the left side border is bigger, usually an inch. Okay, in a larger project where maybe you have 100 drawings, you need that inch just to fold the sheet of drawings open. Okay. In a small project, you can number them more simply. Typically, you will see this numbering system, A for architectural, S for structural. Interesting enough, I rarely see the interiors and finishes section. I don't know where the Kilmer and Kilmer found that, but I was told that interior stuff shows up in the A's. But it may be that in smaller projects, that's the way it's organized. So the process for preparing construction drawings, in a nutshell, is in 5 easy steps. Feasibility. There are a number of things that are going to happen depending on the type of project. For example, if it's a ground-up project, you're going to have a lot of feasibility studies, some programming that happens before schematics. If it's an entirely new project, a lot of that will happen. Certainly, the programming may happen, but things like feasibility studies may not happen. And some of these get compressed if it's a small project. Often, what will happen in an office is you'll mock up the drawing set. Just to kind of know what you're up against. So, and this is something which, when we get to the probably done with design development, we will do one of these for our construction drawing set. It's super handy, particularly as a management tool when you're in an office. If you want to say, oh, wait, okay, I have 3 people working for me. Who's going to do what, and how long is it going to take each of them? This is a handy way of kind of strategically organizing things. So anyway, and we don't need to see every bit and piece of how it's organized, but you obviously want to just get a sense of what your drawings are going to be needed. And I've seen plenty of people do this with their presentations in InDesign or Illustrator, where they kind of leave blank boxes where the stuff is supposed to go. So anyway, and there are some common sizes. In fact, you've probably all, when you go to print, you see like Arch D and Arch E. 24 by 36 is probably the most common. 30 by 42 is Arch E. That's also the larger size. I have never seen a 36 by 48 set of drawings. And of course, the rest of the world is metric, so the sizes are going to be slightly different. Drawing composition, well, again, you're going to probably be using, at least starting with a title block. The big thing to remember is that an inch and a half, they say, for binding on the left. side. Obviously, if you're doing a project where it's like one sheet of drawings, you don't need that edge for binding. Our printer, I believe, can go within 1/4 of an inch of the edge of the sheet, but 1/2 an inch is not a bad idea. So if you look at your title blocks in Revit, I think what you'll find is they're actually measured wise, they're smaller than 24 by 36. They're actually, I believe, 22 by 34, which accounts for all the extra borders. Anyway, and there's a number of strategies, and obviously the one that's probably most peculiar is things tend to be right justified on the sheet, and that's so that as you read through the sheets, as you flip through, the side on the binding is if there's extra space, that's the side it goes on, just because it's where it often gets bound, so you don't want to have some important detail or dimension that's lost there. Although interesting enough, this layout here, they have their plan too far to the left, if you ask me. So anyway, title blocks do sometimes go on the bottom, especially if you have a long linear project. It just fits better on the sheet. And there's certain basic information that goes on the title block. Again, this is something you'll see in the template, but I will ask that each of you come up with your own, including, I believe you all probably have like your own personal logo and stuff like that. Or if you don't, now's probably a good time to start to go into that. Larger offices are going to have other systems for tracking revisions, and within the Revit title block, there's the standard one has like 1 million revisions. So anyway, and these title blocks, this is sort of your one sort of exciting spot in the construction drawings. It's your chance to kind of define yourself and also your client. So that's title blocks. Now, what about sort of more detail-y things like notes on construction drawings? Well, the big thing is that they should be concise, clear, and not prescriptive, right? They should not be talking about products and certainly not installation techniques, but should be general. Now, again, a small project, you may just put the products right on the elevations. But in most projects, and ours is included, you're going to want to use more generic terminology. For example, this one says granite countertop, typical. The specification for the granite is going to occur in the specifications. The same with the hardware, the glass, the door types, all that other stuff. And that's kind of as it's for convenience. If you change a material, a product number, for example, what you don't want to have to do is go to 5 different drawings and change that information. As long as it says granite countertop, you can change the style of granite, or you could call it something even more generic like natural stone, and then allow the specification to cover the exact material. So anyway, there are a number of graphic standards. That's why we have a giant book called Graphic Standards. And again, Revit really helps you a lot with this, but not with abbreviations. So I believe in my years of practice that abbreviations are becoming a lot less common, interesting enough. But they are still used, and you should be aware of what they are, okay? And certainly contractors are going to be aware of them. Things like graphic symbols, legends, dimensions, all of these are going to be sort of built into Revit, and I'll show you places where you can get some of these things. But, you should definitely know what a CMU is, and NIC and HVAC. All of these things are very common. Okay, and you should know not only kind of what they are, but what the words mean. So graphic symbols, again, Revit is going to help you a lot with these. Same with material symbols. Just be aware if you are not sure what material, how it's shown, show it as blank and use a note. Okay, don't put in the wrong hatching pattern because that obviously will confuse people. So, and once again, Revit can help you out in this, and there are ways within Revit to use custom hatch patterns. You might say, but why don't I just render it? Wouldn't that be a lot easier? Construction drawings are never rendered. Okay, there are times where you will show renderings to contractors, subcontractors, particularly for intent. construction drawings are basically never rendered. You use hatch patterns. Okay, and again, I think there's kind of a logic to it in terms of showing them something generic and then specifying a product in the specifications. There are also, meanings to different lines. For example, a center line is a dash dot. Okay, that's the way it is. And a hidden line, there's a reason that AutoCAD and Revit calls it a hidden line, because it represents something which is hidden. Okay. And then there's a number of different things. Section cuts, Revit does it for you. And the walls in plan view can be either solid, pochade, not pouched, or hatched, or shown as empty. Okay, so and graphic symbols, again, Revit is going to help you out with this, but you should be aware that a lot of those symbols, the section symbol, for example, that we use all the time, will fill itself out for you. I've noticed sometimes I see drawings up where there's an empty symbol and it just looks funny to me. So be aware that if you're using that symbol, it's expecting you to drag that drawing onto a sheet and in order to fill itself out. So don't use it if you're not going to drag it onto a sheet. Okay. Anyway, and then some people will get more specific about using hatch patterns to represent wall types. In our case, when we get to the construction drawings phase, so not design development, we will be using one convention, which is solid hatching for new construction, white, solid white, I guess you could say, for existing walls. Anyway, another thing that you typically do in floor plans is dimensioning. And dimensioning is kind of this relentless thing that you might say, why do I even need to bother? Can't they just look on the drawings? I mean, on the electronic document? Well, first of all, they can't because you don't usually give them the electronic documents. And second of all, you don't want them measuring off of a printed drawing. Because drawings are never printed exactly right. It's much better to put a number in there, especially if you know the number and it's a number that you want that's, say, a 5-foot clearance. You should put that number in there. Anyway, usually you have overall dimensions, which are kind of the whole length of the plan. If it's an existing project, you'll type in VIF for verify in field. And then only horizontal dimensions are shown in plan. Only vertical dimensions are shown in section and elevation. The other thing is that typically new interior partitions are shown to their center line. New exterior walls are shown to their finished face. Okay, and existing exterior walls are also shown to their finished face. Here's an old school example, hand drawn, hard to believe, or they used a hand drawn font on their computer. But again, leader lines show the connection to the object that you're measuring. And again, Revit does this for you. So, it's not a big mystery. But try to be as clear as possible. So anyway, you should also indicate where your dimensions are taken. Sometimes, some projects, you are going to be measuring to the center of the wall. That's typically for new walls. Sometimes in a gut project where they are gutting out, say, a kitchen or a bathroom, you're going to have the face of stud visible. So that's where you want them to take their tape measure. And again, anything that's important to have a certain clearance for ADA or other universal design, you need to put that dimension in there as a clear dimension, that you literally use the word clear. Okay. Finally, there is great sadness in my mind that we still use the English imperial system. Even the English don't use the English system. They use the metric system. And actually, if you work on federal projects, which I did at one point, the federal government of the United States is all metric in their construction projects. So you should know how to convert. It's just a mathematical formula, but Revit will do it for you. You just change the units. The real important thing, which I don't believe the book mentions, is that there is something called hard and soft metric. And hard metric means we use actual metric sizes for objects. So a door isn't 6'8", it's 1.8 meters or whatever the exact amount is. We typically don't use hard metric in the U.S. Okay, even federal projects, you use the metric equivalent of 6'8". Okay. But in the rest of the world, and again, some of you may end up working on projects overseas, you'll need to familiarize yourself with metric. And one big difference, of course, is going to be modular elements. We typically use things like drywall, sheets of drywall, sheets of plywood, any sheet goods, even countertops. They are all common standard sizes. Even brick, which itself is not necessarily a standard size because the grout lines are variable. They're handmade, or at least they typically are handmade, although there are industrialized brick panels, but those are typically exterior. Anyway, but we do know that brick coursing is actually standard. 3 courses is 8 inches for your standard American size brick. So often designers, particularly in architectural offices, are going to use modular grids to help them lay out a space. It does tend to save money, particularly in wood-framed projects. So you might use a 16-inch grid to lay out a house because that works neatly with the 16-inch on center wood framing. And metal framing is the same. But there are other things which work on a typical grid. For example, 2 inches is your typical kitchen casework module. So you could use a 32-inch wide base cabinet or a 34-inch wide cabinet. You can certainly use a 33-inch countertop or a cabinet, but there may be an upcharge or a lead time implication there. Even vertical elements, brick coursing is the one. What you'll find is that door frames, metal door frames that go into brick walls, you have to order them with the brick sizing in there, although the lame thing that you always see is that they just make the head of the door an extra couple of inches thick instead of providing you with a consistent width of the door frame. But that's just another weird pet peeve of mine. So anyway, all of this stuff, you might say, well, why do I even need this during the schematic design phase? I'm trying to give you a sense of where we're headed this semester, okay? It's much easier as you're working if you kind of know, at the end of the semester, this is my goal. I don't want people to dawdle and kind of there's this tendency in design studios to kind of mull around picking daisies. We are kind of on a mission here to get to a high level of detail in this project. In general, construction drawings are developed in stages. Often there's a conceptual design phase, which is kind of what you've got at this point. But then schematic design, as I mentioned in our first session, really tests out, okay, is that conceptual organizational scheme really going to work? Can I fit in all the little bits and pieces? In our case, does the pool fit there where it's meant to be with all the railings and the starting blocks and the diving boards and all that kind of stuff? Or is there something that needs to be modified either in the pool dimension or the program itself? Maybe this becomes a diving facility, or maybe this becomes an Olympic-sized pool, 25 meters instead of 25 feet. All of these things kind of get hashed out in schematic design. Design development, you are going to want to look at specific kind of construction systems and assemblies. For example, if you decide, well, let's go with some acoustical treatment where we hang an acoustical ceiling. Design development is the point where you'd start to say, well, let's look at what kind of acoustical ceilings are out there. Obviously, you're going to narrow it down, not just use sort of the Revit 2x2 ceiling, but you're going to say, well, what kind of ceiling is going to get us the best kind of sound control? What kind of ceiling can handle the moisture that is in this sort of facility, what kind of ceiling is going to look good at the scale of this project. It's huge. Maybe something that's more like waves is going to be good. Well, that cuts out the traditional kind of pressed mineral fiber ceiling, but maybe that would look better. Maybe that would have more of an aesthetic appeal. Anyway, design development, you're going to work out all of that, try and decide on all of the assemblies, make sure that your firewalls are constructed as fire-rated construction, and all that might imply, and do a full code analysis. Typically at SD and at DD, you'll be doing a cost estimate, but DD is really where you kind of get a good sense of where you're headed. In fact, if you use an AIA document, the precision of your cost estimate in schematic design, it should be within 25% of the final cost. You own that. That is part of your contract if you're using the AIA document, at least one that's not changed. So you have to pay attention. DD, I believe the standard is within 15%, and CDs it should be within 5%. And I think if you do a CD's cost estimate, which is actually pretty difficult sometimes, you should be better than 5% most of the time, particularly for a public type of project. Anyway, for us, the main implications for what you're doing right now with developing the schematic design is consider those broad issues early. Don't have a situation where it gets towards the end of the project and suddenly you realize you need a HVAC duct running right through, some prime space. And as you'll see, we will do some diagrams to help us figure out like how are you going to get the wires in there? And we talked about that a little bit. Those general strategies, you might say, well, do I really care about the wires? It's just a couple of inches difference on the wall thickness. It's worth thinking about because it may have an impact on how you control sound, how you control moisture in the project, adding to the complexity and also the options for finishes. So, and there you have it. That's kind of an overview of construction drawings for interior design.